afternoon all. This is the week 1 problem solving session of microelectronics device to circuit. I'm Arpita Biswas, a PhD scholar from IIT Jodhpur. So this is the basic introduction about me. I'm Arpita Biswas, and I did my BTech from West Bengal University of Technology, Kolkata, and I did my MTech from IIT Jabalpur in Microelectronics, and recently I'm pursuing PhD from IIT Jodhpur in electronics and I'm working on the biosensor, 2D material based chemi-resistive biosensor. And mainly it is device and my research work is based on to fabricate the 2D material based biosensor. So this is more details about me, and this class schedule is every Tuesday 7 to 9 p.m. So in this session we are basically going to discuss about some of the question answer, and I hope all of you will participate in this session. So I want each and every one of you will participate on this, and I expect at least you will try. So this is the first session of this microelectronics device to circuit session. So we are going to start from very basic level. So and we are discussing all the session whatever sir has taught you in this. So we are basically going to solve the question, and by the solving the question answer time we are going to clear your doubt also. So let's start the session. And in the question answer session I want everyone, each of everyone you will participate, and please unmute yourself and try to give the answer. Whatever the answer, it is right or wrong, it does not matter, but at least you should try. It is my expectation. So we are going to start the session. This is the question 1. It's a very simple question, and I think all of you can give the answer. So okay. So the circuit symbol represent, the first option is NPN transistor, the second option is PNP transistor, the third option is the Zener diode, and the D is PN diode. This is the very basic question, and I hope all of you gone through the lecture whatever the Professor Shudev Das Gupta taught you. So I think all of you can give the answer. Okay. And this is very basic question, I think. It will be a little bit easy for you. Can please unmute yourself, so it will be more interactive session. Okay, so please try unmute yourself and then give the answer, so others also can.
Ma'am, the answer will be NPN transistor.
Okay. Can you explain it?
Yes, ma'am, because in case of NPN transistor, we are having the N-type emitter, P-type base, and the N-type collector. where we can find that in the emitter, when the current is flowing from the electron flowing towards the collector, the current should flow in the opposite direction of the electron. So it is out of the it is going out from the emitter. So as the arrowhead is away from the base, the current should be away from the base. So that's why the arrowhead indicates it is an NPN transistor.
Okay.
It is away from the base.
Okay. Sunkara Ganesh, please unmute yourself. And what is the right answer? Actually, I want all of you at least try and please unmute. Then it will be the interactive session mode. And all the theory part, I think you have gone through the lecture. So it is just to check your basic knowledge about the BJT. So
Ma'am,
yes, Kavya.
the arrow indicates the current direction, ma'am.
Okay.
In this, the collector, the NPN transistor means the emitter is N-type and base is P-type and the collector is N-type. So in this, the current will flow from emitter to base.
Current will flow from emitter to base.
Sorry, ma'am. The electrons will flow from emitter to base. So the current direction is opposite to the electrons' movement.
Okay. Abhay. Abhay, please unmute yourself.
Yes, sir.
What type of transistor it is, or what type of bipolar BJT it is?
Hello.
Yes. What is the right answer? Abhay, what is the right answer?
Sorry, ma'am. I joined just now.
Yes, this is the first question. That here is a symbol you can see now. So what type of symbol it is? Like the circuit symbol represent what type of transistor? At least try. I know.
NPN trans.
Okay, NPN transistor. Actually, I know all maximum at least 99.99% student know what type of symbol it is. But I want all of you, whoever don't know the answer, at least try, and if you have any doubt, then we can clear. Okay, Shamuel, your answer is right. Okay, now you can. Hello. Bhavani. Jayashree, please unmute yourself and try to give the answer.
Yes,
What type of transistor it is?
it is NPN transistor.
Okay. And
As the reason is the electrons are moving from N side to P side. That is from emitter to base. So the direction of current will be opposite to the movement of electrons.
good. So I think all of you got your answer. So we are moving toward the question number 2. Samuel, you can mute yourself, I think. Noise is coming from your side. So we are moving towards the next question, question number 2. The majority charge carrier in NPN transistor are, first option is electron, second hole, and third option is trivalent atoms, and the fourth option is pentavalent atoms. Okay, sure, but I will ask you later. At first, others, I know you know the answer. I will ask you later. Sukara Gansel. Sukara Ganesh. So, Sukara Ganesh. What is the right answer? Please unmute yourself. At least try. All of you know that there is a, yes. What is the answer? Hello? Sunkara Ganesh? Am I audible?
Yes, ma'am, you're audible.
Electrons.
Okay. And what is the minority carrier?
Holes.
Okay. And if it is PNP type, then what happened in that case? You have told that in NPN transistor, the majority carriers are electron. So if it is
true. Vice versa.
okay,
Okay.
Meghna, what is the right answer? Please unmute yourself. Then this session can be interactive. I know this is a very easy question and this is the basic question, so I hope all of you know the answer. But I'm putting this question in the slide that to check your basic knowledge. If it is not clear, then we can clear here now. This is the basic question from the BJT. So I think all of you can answer this. At least try. And I know some of them are very good in this subjects, and some students coming from the BTech background, or someone is coming from MTech or something else. So we are starting this session from the very basic, so that if someone is not that much knowing this knowledge of this subject, so we can. Okay, Sukara Ganesh, NPN and majority is electron. Okay. Tarun, what is the right answer?
Ma'am, it's electron.
Okay. And the minority?
Ma'am, holes.
Okay. Okay, so next we are moving towards the next question. Question number 3. So the number of depletion layer in the transistor is. So the first option is 2, 3 or 4 or 5.
2 depletion layers, ma'am.
Where the depletion region is formed?
First one is emitter and base, next base and collector.
Okay, good. Bhavani, what is the right answer?
Now, 2 depletion layers, no?
Okay.
One is the emitter and base junction, and other one is collector and base junction.
Okay. Good. Tarun, what is the right answer?
Ma'am, option A2.
Okay. So we are moving towards the question number 4. BJT is a voltage control device. The second option is the current control device, and the third option is the very high input impedance device, and the fourth option is none of the above. Please unmute yourself and try to get the answer.
Current control device.
Current control device.
Okay. Can you explain why it is a current control device? Anyone? Please unmute yourself.
Collector current will be controlled by the base current, input current, in CE amplifier, in CE mode.
Okay. Anyone else?
Output current will be controlled by the input current. In CE configuration, collector current will be controlled by the base current.
Anyone else?
Ma'am, the input current is controlling the output, so that's why it is a current control device. We can see that the base current is controlling the collector current, because as much as the recombination is less in the base, that much more current we can get in the collector. So if we can make, that's why the base, we used to keep the base as very light doping, so that the recombination of the carrier in the base region is very low, and due to that we can get the maximum number of carrier in the collector side. So the collector current is controlled by the base current in this way, so we can configure that it is a current control device. Input current, base current is controlling the output current.
Good. Anyone else? Saujana, what is the right answer? Please unmute yourself. Paribi, Meghna, please unmute yourself and try to give the answer. Kavya,
Ma'am,
yes. I think you gave
ma'am,
the
I don't
answer.
know the exact reason, ma'am.
Jayashree,
Current control device in which voltage applied between two terminals is controlled by current flowing in the third terminal.
yes. Yes, you are right. So next we are moving toward the question number 5. Identify the correct equation regarding a transistor. So here what is, yes,
Ma'am, answer the before question.
yes. Actually, whenever the current is there is a three term. This is the transistor is three terminal device. So whatever we are like, if we are taking an example that it is the electron flowing from the electron, here is the first reason is emitter, then base, then collector. So if and there is a three terminal, so from one terminal to another terminal when the current is flowing, so we can control by the third terminal. Okay, so current, if it is flowing from the electron is flowing from the emitter to collector, so by base current we can control it. So when the current is flowing from one terminal to second terminal, another terminal, by third terminal we can control. That's why it's behave like a, sometimes it's behave like a switch. Okay, so this is the, like here to here the current is flowing, so by the third terminal we can control it. Sometimes it's can like an open circuit, like when we are taking an example that is switch. Okay, so when we are controlling it from the third terminal, so we can connect this two terminal, then the current can flow, or we can open. Okay, like that. So by one terminal to another terminal, when it is flowing by third terminal, we can control it. That's why it is called the current control device. So you got your answer?
Yes, ma'am.
Okay. So the question number 5 is identify the correct equation regarding a transistor. So the first option is IE less than IC greater than IB, or the second option is IE plus IC equal to IB, or IE greater than IC less than IB, or the option D is IE greater than IC or greater than IB. Take your time, but at least try to give the answer. Okay, Samuel. Okay, Navodaya.
Ma'am, option D, ma'am.
Okay.
IE is larger than IC is larger than IB, ma'am.
Okay.
D is correct, madam. I is equal to IC plus IB.
IE equal to, sorry,
IC plus IB.
But here this equation is not given, na? Option B is IE plus IC equal to IB. So is it right or wrong?
D.
Okay, option D. Okay.
I put D.
Meghna, what is the right answer? Okay, Sukara.
Ma'am, D, ma'am.
Okay. Okay, so the right option is option D. Can anyone explain little bit about it? What you know about this emitter current, collector current or base current?
Ma'am, IE is heavily doped, so more current will be passed on.
Okay.
IC is lightly doped, and base is moderately doped, but its layer is thin. So its current is thin when compared to IC and IE.
Okay. Anyone else? Which one is lightly doped or which one is moderately doped?
IC is moderate. IC is lightly doped, IB is moderately doped.
What do you
No,
mean by-
ma'am.
IC,
Base is lightly
emitter,
doped.
Yes.
emitter is heavily doped, IC, collector is moderately doped, base is lightly doped.
Yes. So this is the right answer. That electron is emitter is highly doped and collector is moderately doped and the base is lightly doped. Okay, that's why the the emitter current is higher than the collector current and it is also higher than the base current. Okay, so here the right option is option D. So if anyone have any doubt, then you can ask. And please unmute yourself rather than write in chat box. If you are facing some issue of network, then it is okay, but you can try, you can unmute yourself and then try to give the answer. So we are moving towards the next question number 6. So identify the main function of BJT. So first option is acts as an amplifier, second option is acts as a switch, and the third option is acts as a rectifier, and the fourth option is both A and B.
Ma'am, both A and B.
Okay. Anyone else?
Ma'am, option D.
Okay. Anyone else? Sikara. Okay. Can anyone explain a little bit about it?
Ma'am, in the saturation and cutoff region, the BJT act as a switch, and active region and reverse active region it act as amplifier.
Okay. Anyone else?
Ma'am, the main function of BJT is it acts as an amplifier in the active mode of operation, because in case of BJT we can get the maximum amplification of the input voltage we get. In case of C amplifier we can find the negative phase shift and the 180 degree phase shift amplification. So the main function of BJT is amplification as an amplifier.
And it also acts as a switch. So the right option is option A and B. So anyone else who can give the explanation about the BJT acts as a switch?
Ma'am, BJT acts as a switch in two conditions. In on condition, when the BJT is in saturation mode, that is the emitter base junction and the collector base junction both are forward bias. That is saturation. It is an on switch, and when it is reverse bias, that is cut off mode. The emitter base and the collector base both are in reverse bias condition. It is acting as an off switch.
Okay. Tarun, what is the right answer? I want all of you at least try. I know some of you are very good in this subject, so you can give easily the answer. But I want all of you at least try. Whatever the answer, right or wrong, then we will discuss. Tarun, what is the right answer? Please unmute yourself. Okay, somewhere. Option D. Navodai, M. Navodaya, what is the right answer?
Ma'am, both A and B.
Okay. Can you explain the mode of this BJT? Like when it is acts as a saturation mode, when it acts as a active mode, or when it is in cutoff mode? Can you little bit explain about it?
Ma'am, can I?
Okay.
Ma'am, the BJT act as saturation mode in when the emitter base junction and the collector base junction are in forward bias, and it act as cutoff mode when both the emitter base and the collector base junction are reverse bias.
When it is
And in
reverse bias, then it is acts as a it is in cutoff mode. Okay. And when it is reverse active mode?
Reverse active mode is collector base junction is forward bias and emitter base junction is reverse biased.
Okay. So here, in what mode the BJT acts as an amplifier?
Ma'am,
Forward
I
active.
think, yes, ma'am.
Yes.
That is okay.
And in forward active mode, what type of bias is there? It's mean forward. Which one is forward and which one is reverse?
Forward.
Emitter base is
Emitter
in
base
forward
is
bias.
forward.
Okay. And the collector
And collector base is reverse bias.
Okay. And in which mode it acts as a switch?
Ma'am, in off switch it is cutoff region, ma'am.
And in cutoff
And on
region,
switch it is
which
saturation.
bias is in which condition?
Ma'am, both the junction are reverse biased.
Okay. And when it is 1, but it means the
Ma'am,
switch
I
is
can't
1.
understand. Oh, it is on, it is saturation region, both the junction are forward biased.
Okay. So I think this question is clear to all of you. So we are moving towards our next question. This is the question number 7. Which of the following represents arrow in BJT symbol? Flow of current, flow of resistance, or direction of current, or both A and C? So what is the right answer? Which of the following represents arrow in BJT symbol?
Ma'am, both A and C, I think. Flow and direction of current.
Okay. Next, anyone else?
I think only flow of current.
The flow of current is representing the arrow in BJT symbol. Okay.
Yeah, yes.
Anyone else?
Direction of current.
Okay. Some direction of current. Okay. Anyone else? Sankara Ganesh? Okay. Option C. Tarun, please unmute yourself. And if you are facing any
Direction
issue,
of current.
okay. Can you repeat? Sankara Ganesh. Meghna, what is the right answer? Karthikay Dubey.
Direction of current.
Okay. Jayashree, what is the right answer?
Okay.
Okay. So here the right answer is option C, direction of the current. When we are indicating any direction, in that way we are indicating the direction, the arrow. So arrow indicating the direction where it is the direction of the current, where the current is flowing. Okay. So this is not the flow of current, this is the direction. It is also the direction. Actually the current is flowing, so arrow is indicating the direction. So the right option is option C. So next we are moving towards the question number 8. Which of the following junction in BJT is forward bias? Emitter base, collector base, emitter collector, or both A and C? actually it is in active mode.
Ma'am, the emitter base junction.
Okay.
Option
Yes,
A.
ma'am. Emitter base. Option A.
Okay. So Kara Ganesh, what is the right answer? Option A. Okay. Jayashree, what is the right answer? Both A and C. If it is in active mode, in that case, which one is in forward bias, Jayashree?
Emitter base.
Okay. Meghna, please unmute yourself. What is the right answer? Sudharshan.
Ma'am,
Yes.
is the question for active mode, ma'am?
Yes, if it is in active mode in that time, which junction it is in forward bias?
Emitter base, ma'am.
Which one? Kavya, can you please repeat?
Base to emitter junction is forward biased.
Yes, you can unmute yourself and you can give the answer. Whoever raised your hand.
Not the emitter or collector. So,
Your voice is not clear. Can you please speak loudly? Hello. I think multiple time we have discussed then in which mode which biased in BJT is in forward bias and which one is reverse bias. So here if you are considering it that this BJT is in an active mode, in that case which bias it is in forward which is the BJT in forward bias in which so what is the right answer here? Panty Sullivan in Pandy Silvana. Can you please unmute yourself and give the answer? What is the right answer? You can write also if you are facing the network issue. Yes, the right answer is option A. So next we are moving toward the question number 9. And actually this question is already discussed in earlier. So which of the following terminal in BJT is always maintained in reverse bias state in active mode?
Collector base junction.
Okay. Anyone else?
Collector base.
And if it is saturation, then
Both of the junctions should be forward bias in saturation. Emitter base and collector base both should be in forward bias.
okay. So next question is which of the following terminal of BJT emit a carrier to other terminal? The first option is base, second option is the collector, third option is the emitter, and the fourth option is the both A and C. So what is the right answer?
Option C will be the correct answer. Option C.
Okay.
That is the emitter.
Okay. Anyone else? Samuel, can you explain why emitter or option C is the right answer? Can you little bit explain?
Ma'am, actually the emitter terminal, we used to keep the emitter as the highest doping region. We dope the emitter with the highest carrier so that it can inject as much as the carrier to the collector region. And the collector region is the widest region as so that it can collect as much as the carrier it is generated from the emitter region. So emitter is the, and from the name itself it is emitter, so it is emitting the carrier. So emitter is the region which is emitting the carrier towards the collector.
Shaurabh, are you a BTech student or MTech?
Ma'am, actually I am a faculty of a college.
Okay. So where are you teaching?
Ma'am, I am in Kolkata. I'm teaching in Dream Institute of Technology. I just started my career in 2 years back. I completed my MTech 2 years back, and I just started my assistant professorship in the college. So this is my beginning of my career.
Okay. So after MTech, you have joined as a faculty.
Yes, ma'am. After completion of my MTech from Heritage, I have joined as a faculty in Dream Institute.
Yeah, and in which institute you are now a faculty?
Ma'am, I am working as a faculty in Dream Institute of Technology. It is in Kolkata, Dream Institute.
Okay.
It is in Thakurpur.
Okay. And your background?
I have completed my EC BTech from GIS, and I have completed my MTech in VLSI from Heritage Institute of Technology, Kolkata. Both are under Maulana Abul Kalam Azad University of Technology.
Okay. Actually, I did my same
Yes.
BTech degree from the same.
Yes. I saw in your introduction. Previously it was WBUT. Now it's changed to back out.
Yes.
Thank you.
So, what is your future aim?
Ma'am, I just started my career, but I am having my planning to enroll for the PhD, because for academic background, the PhD is a very much required. But the learning is the best part that I love to do in the academic field. Every time I used to learn, even from the other faculty members in our faculty room, we used to learn a lot. But the PhD is the main goal that I used to look forward in near future, so that I can complete it.
So
my
you're
environment.
interested in analog portion or device or the digital?
Basically in the device portion, means I used to teach the device and analog, both I used to teach, but my interest is mainly in the device portion.
Like device fabrication?
Yes.
Sensor and those things.
Sensor and yes, the fabrication I used to, means if possible, if I get a chance to do, I will be definitely, it will be my first priority.
Actually, I'm also working on this fabrication based.
Yes ma'am, I looked into the part in the introduction. Thank you.
Good.
Thanks.
So next we are moving towards the question number 11. A BJT operates in dash number of region. So what is the right answer?
3 regions, ma'am.
Can you explain? Kavya, what are these 3 regions? Somewhere 4. Okay.
Saturation region and active region.
Okay. Samuel, can you explain what are those 4 operating region?
Cut-off region, active region, reverse active region, saturation region.
Okay. Actually, normally we are not done this reverse active region. Okay. When we are going do the measurement or so we are basically working on this 3 region, and whatever you have told, these are the mode of operation. And if you are talking about the region, number of region, then it is 3, the cutoff, and then the saturation, cutoff, saturation, and then the active region. Okay.
Yes, madam. But one more region, reverse active region, when input is reverse biased and input circuit is reverse biased and output circuit is forward biased, then it's not much in use, but it is reverse active region.
Yes, this is the another type of mode, I think. Yes, the reverse active.
The reverse action of the forward active region.
Yes. And the next next question is next question 12 is which of the following is the formula for BJT active region? IC equal to beta into IB, IC equal to beta by IB, or IC equal to beta plus IB, or IC equal to beta minus IB.
Ma'am, correct option is option A. IC equals to beta into IB,
Okay. Anyone
where
else?
beta is the sorry, ma'am.
Okay, you continue.
Beta is the current gain, forward current gain in the common emitter configuration, and IC is the collector current, IB is the interface current. So here the correct equation will be IC equals to beta into IB.
Anyone else? What is the right option? I think this is a very basic question, so all of you know the answer. Someone,
option
what is
A
the
only.
right answer?
IC equal to beta into IB.
Okay. Sukara Ganesh, what is the right answer? Please unmute yourself.
Beta is the current amplification factor.
Okay. Tarun, what is the right answer? Yeah, okay. If you are facing technical issue, then you can write here, no? Sukara Ganesh. Okay, option. Jayashree, what is the right answer?
IC equal to beta into IB, where beta is current gain.
Okay. Meghna, what is the right answer? So the right option is option A. Next we are moving towards the question number 13. What is the cutoff voltage value of BJT? The first option is equal to 0.7, second option is less than 0.7, third option is greater than 0.7, or the fourth option is 0.9. So what is the right answer? The cutoff voltage value of BJT.
Less than 0.7, ma'am.
So correct option.
Ma'am, option A is the correct answer. Knee voltage is 0.7 volt for silicon.
Okay, but when it is aimed this cutoff region and it start to the saturation or the active region, this is the
So
question.
basically, thing greater than 0.7. C option.
Okay. Anyone else?
Less than 0.7, ma'am.
Can you explain why it is less than 0.7?
Ma'am, because the new voltage is 0.7, ma'am. So less than knee voltage, no current will flow. That is equal to the cutoff region, ma'am.
Okay, but what is the cutoff voltage value? It means when the cutoff region ends and it start to saturate or it is entering the active region. When it's just the starting point of some value. So if it is greater than that value, then it will be the start to enter the saturation or the active region. So this voltage is known as the cutoff voltage. It means slightly greater than that voltage, so the BJT can start to operate. So I think I gave the hint. So what is the right answer in that case?
B is answer, madam.
Okay. Anyone else? Tarun?
Cut-in voltage is 0.7, madam. When it is input voltage is less than 0.7, it will not operate.
Operate. Yes.
It will not be forward biased. So input junction will be cut off. So it's off.
If it is greater than 0.7, then it will start to operate. So here
Yeah.
yes. And so here the right option is option B. So So we are moving toward the question number 14. What is the equation of current gain in BJT common base configuration? So first option is IC by IE, second option is IE by IC, the third option is IB by IC, or the fourth option is all of the above.
Ma'am, option A is the correct answer. IC by IE.
Okay. Anyone else?
Option A, ma'am. Current gain is alpha. Alpha is equal to IC by IE.
Okay. Anyone else? Sukara Ganesh, what is the right answer? Okay. So you can unmute yourself and you can give the answer.
Madam, in common base, output current is collector current,
Okay.
input current is emitter current. So amplification factor is alpha IC by IB.
Good. JST, what is the right answer?
I said no, from current gain is alpha, so alpha is equal to IC by IE.
Meghna, please unmute yourself. Sojourn, what is the right answer? Sudarshan, please unmute yourself.
Ma'am, option A.
Okay. Can you explain it? I think some of them are explained very well. So if you heard it, so you can explain. You can able to explain it. So please try to explain why option E is the right answer. Sudarshan? Can anyone explain again? Samuel, can you explain again?
Yes, madam. In common base configuration, base terminal is connected common to input junction and output junction.
Well, base
So
terminal
input
is
current is
grounded.
emitter current,
Yes.
output current will be collector current. So emitter current is the input current, output current is collector current.
Yes.
So output current by input current is amplification factor, that is alpha. So alpha equal to IC by IE.
Good. Sudarshan, are you getting the answer? Sudarshan? Okay, next we are moving to the next question. I think this is a very which of the following terminal is grounded in common base configuration of BJT? Base, emitter, collector, and all of the above. So this is very easy question.
A.
I think all of you know the answer.
Yes, madam.
So in common base, which one is grounded?
Ma'am, the base is grounded.
Okay. Anyone else? Please unmute yourself and try to get the answer.
Yes, current element.
Okay. Saujanya, what is the right answer? You're actually already in question, you can see the answer. Which of the following terminal is grounded in common base configuration? Okay. Good. Sudarshan, what is the right answer? Okay. Good. base. Okay. Next we are moving to a question number 16. Which of the following BJT configuration has maximum power gain? Common base, common emitter, common collector, or all of the above?
Then the common emitter, option B.
Can you little bit explain whatever you know about this?
Ma'am, in case of common emitter configuration, it is the most preferred because we are getting the most part of the carrier means that emitter is ground in case of the common emitter, where the base current is the input current and the collector is getting the output. We are getting the output from the collector in. So we are getting the maximum current due to the transfer of the maximum number of carrier, and due to which we are getting the maximum power gain, and we get the amplification, highest amplification or the exact amplification in case of C configuration. And amplification means the increase of power, which implies the increase of the power.
Yes. Good. Anyone else? What is the right answer and why? Someone, what is the right answer? Okay, so okay. Meghna, please unmute yourself. And please
Am I
find-
audible?
Yes, you are audible.
Common emitter has more power.
Jayashree, what is the right answer?
Common emitter.
Okay, so the right option is common emitter. So we are moving towards the question number 17. And this is also the very basic question. Identify the equation of common emitter current of BJT. I equal to IC plus IB or I equal to IC minus IB. I equal to IC by IB or the I equal to IC into IB.
Ma'am, option A.
Option A, ma'am. IE equal to IC plus IB.
Yes. Anyone else? I think all of you know the answer. At least unmute yourself and give the answer. Sudarshan? What is the right answer?
Option
Sojan, what is the right answer? Meghna? Okay. So the right option is option A. So question number 18. The base of an NPN transistor is thin and heavily doped, lightly doped or metallic or doped by a pentavalent material.
Ma'am, option B, lightly doped.
Okay. Anyone else? I think this question we previously discussed. Which reason is dope? Can anyone explain a little bit about all this base region and collector or emitter region? Which one is dope?
Basically, the doping levels are the emitter should be the maximum doping, base should be the lightly doping, and the collector is moderately doping. Now, the reason is why the base is lightly doping, that is max, so that the recombination chances should be less in the base, so that we can get the maximum amount of carrier received in the collector end. So that if we dope the base with light doping, then the recombination of carrier will be very low in case of the base, and maximum carrier will be coming to the collector. We will be getting the maximum amount of output current. And emitter is heavily doped because so that it can emit as much as number of carrier, so that as much as number of current can be conducted.
So this is the question number 19. Most of the electron in the base of an NPN transistor flow out of the base lead into the collector, into the emitter or into the base supply. So what is the right answer? Most of the electron in the base of an NPN transistor flow out of the base lead into the collector or into the emitter or into the base supply.
Ma'am, option number D, into the base supply. Out of the base line. Because in case of the NPN transistor, the emitter base transistor is forward bias. So that means the base is given a positive doping. So in case of the base, I am giving a p-type base, but the electrons have the minority concentration. So that reason the emitter should be, the electron should be thrown towards the out of the base, towards the positive supply, not towards the emitter.
Okay, not towards the emitter. And why not option B?
Why not option
B? Most of the electron in the base of an NPN transistor flow. So if the electron in present, carefully read the question. Most of the electron in the base. So whatever from the electron is coming from the emitter to the base, or so where it is goes. If it is an NPN transistor, then in which direction the electron will flow?
It goes into the collector, no?
Yes, it goes into the collector region. And if you are taking, like we are taking an example that it is in active mode. So in that concept, we can tell that the emitter it is in forward bias, and if the collector is in reverse bias, in that case what happened? It means what is the impact of this biasing? This in active mode we are using the bias condition. In that case what happened? How the electron will flow, and what happened in the depletion region? Can anyone explain?
Ma'am, the depletion region in the emitter base junction will be very much thin, because I am giving forward bias in the emitter base junction, and the collector base junction, the depletion region will be thicker as the reverse bias is applied. And another thing is the reverse bias is more than the forward bias I am applying to the returning base to emitter junction.
So what happened in that case about this electron?
The electron in the base.
No, actually I am telling about when you are the BJT is in the active mode, or the emitter base it is in forward and the base collector it is in reverse, and the V is VCB is greater than very much greater than about this emitter base junction. In that case what happened? What happened about this electron, like how the electron will flow, how it is moving into this collector?
Actually, as the bias is very much strong in the VCB, so as the collector is given with a positive NPN, so N collector, so the N-type collector is given with a positive bias, so that will attract the electron towards the
Yes. So this formula or this thing is happening also here. When the electron here the electron is present, which is it emitter, it is goes to the base, then it is moving towards into this collector region. That's why the right option is option B. So now it is clear, or I have to explain again? So the right option is option B.
Yes, ma'am. Option B will be the right option.
Yes. Someone, can you explain it, whatever I have told here? How the electron will flow, like in active region what is happening, and how the electron is flowing from this emitter to this collector. Because when it is an active region, the junction, the width of this junction is thinner at the emitter and the base junction, but the width of this junction of the collector and base is wider than this emitter and base. what happen in that case when we are giving the larger reverse bias to the base to the collector, that positive there is a, and it is an NPN transistor, so there is a plus charge is coming, and when the electron is in, and the first junction it is thin, so electron is easily moved towards this base, and the base as the voltage reverse bias voltage is increased, so in that case what happened, the junction is wider, junction width is wider, so the base region is decreases, so it can easily move the electron from this emitter to base to the collector, and also in that the collector portion there positive charge is there, so it attracts the electron towards the collector. So now it is clear. Hello.
Ma'am, I have a question. When the collector is a N-type material, right? So what about the electrons in collector?
So what about the collector? Yes.
The
Saurabh, can
electrons in
you
collector.
just a minute. Saurabh, can you explain the answer? Or anyone else?
Yes, ma'am. What is the question?
The question is this is the NPN transistor. This is a very good question. This is the NPN transistor. So the electron is the majority carrier in emitter also electron, and the collector also the electron. So if the current is coming towards the emitter to the collector side, but there is also electron present in the collector region. Okay. So what about this electron? I think this is a hard question.
Actually, the collector to base terminal is given reverse bias. So as a result of this, the electron the electron in the collector, which is the majority, the doping of the collector is not as high as the emitter. So emitter is given the maximum doping, but the number of carrier in the collector is lower than that of the emitter. So that collector will be there in the collector. The carrier will be in the collector, and that due to the positive bias I am given. So they will, as the positive bias of the collector is much strong, so that carrier in the collector will try to attract it towards the positive bias.
Yes.
Of the PCB.
Yes, that's why the electron is flowing from the emitter to collector, and the width, as we are giving the reverse bias to the collector to base junction, then the width of this junction is wider, so electron can't flow from this emitter to it little bit needs some more voltage or more so it's face some issue to move from the collector to the base. Okay, so as the electron from the collector side, the positive plus charge is there, so it's attract the electron from the emitter, which is coming from the emitter to base, so it can easily cross this junction and it can goes into the collector, but the opposite is not happening, because the wider the junction, the width, and also the doping. Okay, so I think you got your answer. Now it is clear to you?
Yeah, yes.
Okay. So this is the question number 20. Why an ordinary transistor is called bipolar? The first option is because the transistor operation is controlled by majority and minority carrier. The second option is because the transistor operation is carried out by only the majority carrier. The third option is because the transistor operation is carried out by only minority carriers, or the option D, none of the above. So what is the right
Option
answer?
A will be the correct answer, both majority and minority carrier.
Okay. Anyone else?
Option A, ma'am.
Yeah, madam. Option A.
Can anyone explain it little bit? The answer, why it is the because of transistor operation. Okay, something option.
In BJT,
Yes.
there is total current is total current will be addition of due to majority carriers and minority carriers. The leakage current, due to minority carriers there is a leakage current. Due to majority carriers,
Sure.
main current.
Okay.
output current.
Ashura, can you little bit explain about it?
Because ma'am, it is due to from the name itself, it is bipolar. That is, the current conduction is for both magnetic and magnetic area. As we are taking two p-n junction diodes that placed together to form the BJT. So as we know that in case of a p-n junction diode, the current conduction is because of both magnetic and magnetic. So as we are taking two BJT to p-n junction diodes, so both the magnetic and magnetic area is playing the role for the conduction of current, where in case of an NPN transistor, we are seeing that the majority current is the electron current as the minority current is the hole current, so that the BJT is a bipolar device. Because two p-n junctions are placed together, so the operation of p-n junction is both the hole and electron current will be taking part in the main current, the current equation.
So the right option is option A. So next we are moving towards the question number 21. In a BJT symbol, the arrowhead is always marked on the option A is collector, option B is emitter, option C is base, and option D is none of them. Kavya, yes. What is the right answer?
One emitter.
Okay. Kavya, what is the right answer?
It emits the electrons towards the collector.
No. The arrowhead is always marked on the collector, emitter, or base.
Unlimited, madam.
Okay, emitter. Kavya? Jayashree, please unmute yourself. What's the right answer?
Emitter.
Tarun, what is the right answer? Am I audible? Hello?
Yes, ma'am, you're audible.
Okay, the right answer is option B, emitter. Next we are moving towards the question number 22. The emitter current is always the dash one, the largest, smallest, or medium, or none of the above.
Madam, largest.
Yes. Anyone else?
It is the largest one.
Largest because it is heavily doped, ma'am.
Yes.
And it is a summation of base current and collector current. I equals to IB plus IC from each of them.
So this is the next question, question number 23. Why the width of the base region of the transistor is kept very small compared to the other region? The option E is to pass most of the injected carriers to the collector. The second option is to block most of the injected charge carriers to the collector. The third option is to cut the cost of the fabrication. Or the fourth option is all of the above.
So option number A, to pass most of the injected charge carrier to the collector.
Anyone else? Kavya, what is the right answer? Somewhere you can also unmute yourself and you can listen.
the base region is lightly doped, madam, and the emitter current will pass to the base, and then when the depletion layer of the when the width of the base reduces, current goes from emitter to collector. So the electrons which are injected to the base, they will be transferred to the collector.
Okay, anyone else? Kavya? What is the right answer?
Yeah, ma'am.
Can you little bit explain? If the base field is thin, then what happen in that case? If it is the base width is larger or it is greater than the emitter or something, then what in that case what happen? Yes, Jayasri, what is the answer?
If base width is small, then recombination takes place. So
And Ravi, can you please speak loudly? Kavya, if the base region is thicker or wider, in that case what happen? Kavya?
After the capacitor, madam. Hello.
Actually, your voice is not that much clear.
It will act as a capacitor.
Okay. And what about the recombination?
Yeah, because of recombination, both majority and minority areas are stagnant with the base. The current can't move from emitter to collector.
Yes. Okay. So, anyone have any doubt?
It will act
Or
as a
this
capacitor.
question is clear? Kavya? Please unmute yourself. Tarun? Here what is the right answer, and if the base region is thin, then what happen, and if the base region is wider, in that case what can happen? Tarun? Bhavani? What is the right answer?
I think the right answer is A. To pass the most of the injected charge carriers to the collector. If the oxygen is very thin, then that recombination will be reduces and that electrons will pass through the base easily and reaches to collector. If the base region is very wider, then the recombination is more and the electrons will take more time to pass that region. And one more question I have. When we apply reverse bias to the base and collector junction, then there is a negative ion present at the collector and base junction, right?
No, actually, if it is NPN transistor, then the majority carrier electron is present in the the collector region and also the emitter region. Okay, then.
No, one more time. Once again, can you explain once again?
If it is NPN transistor, what happen in that case? N type, it means the majority carrier is electron. What Okay, so in here two things is like matters like the doping. Here the in emitter junction, or sorry, in emitter the doping is more slightly more than the collector side. Okay, so here the electron, as the majority carrier both is the electron, so the doping is greater in the emitter side. So that's why the and also in the B it is p type. So what happened in that case in active region, I have told that in active region the emitter and base is in the forward bias. So if it is in forward bias, the electron easily can go through this emitter to base. And what happened, whatever the electron present in the collector side, why it is not going to the collector to the base? It only, what happened in that case when it is in forward bias, and forward bias is greater than that this reverse bias, which is the emitter and base. So what happened in that case, this reverse bias is greater than, and it is also there is a positive yes, this is attract the electron from which is coming from the electron emitter to base. So this sides are emitter to base and base to this collector. It can, the electron can easily flow, as the it is this emitter side where when we are adding the reverse bias now. So the reverse bias means what? It is in type, and here we are adding the plus voltage. It means when we are reverse bias means in type is connected to the positive side. So this positive is attracting the electron from this which is coming from the emitter to base. Then it is attracting towards this collector. So the electron can flow from the emitter to base and base to the collector. But whatever electron also present, it is also n type the collector. So why it is not going back to the base? This is your question, okay? Am I
Yes,
right?
ma'am.
Yes.
No, ma'am. Actually, I'm clear about that one, but I'm asking like when we apply reverse bias across the collector and base junction, reverse bias means the negative charge will accumulate on the one end of the collector, and positive charge will accumulate on other end of the collector, right?
Just a minute. It's simple things. Reverse means p type is connected to the negative side, and the n side is connected to the positive side. Okay.
Yeah, ma'am. So when we apply negative bias means reverse bias. So
Actually,
base.
I'm clearing one more doubt that reverse bias, it is not only that negative charge we are giving. Okay, it is positive. Here the positive of the positive side is connected to the n. This is NPN transistor. It means we are connected the plus, we are giving the positive terminal to this p. So there is a plus sign. We can you can also go through the lecture. You can see there the plus sign is present because this n is connected to the plus. It is that's why it is reverse now. If the n side is connected to the negative, then it will be the forward bias. That's why the plus charge is there, and it is attracting the electron which is coming from the base, emitter to base. Yes, now it is clear.
Yeah, okay.
So next question is question number 24. Which is the most preferred configuration for cascade amplifier? The first option is common base. The second option is common emitter. The third option is common collector, or the option D is all of the above.
Common emitter.
Kavya, what is the right answer?
Reflected as follow, ma'am. It's FET gain.
You have heard about the amplifier, right? So in cascade amplifier or normal, as we are taking the normal amplifier, so which condition, which common base or this common emitter or common collector is useful for this amplifier?
Option B, common emitter.
Okay. And if it is in common base, in that case, where it will use?
cascade.
Ravi, your voice is not clear. Can you please write? Jayashree, what is the right answer?
What are cascade amplifiers?
Have you heard about the cascade condition when you were, I think in control system also in BTech you have heard about the cascade or the signal processing also we can see the cascade connection. Anyone who have heard about the cascade connection? You can simply take as an amplifier, okay? Here also. So in which configuration the question is in which configuration the BJT acts as an amplifier? Common base, common emitter or common collector? Go through the lecture video, I think lecture number 5, where which connection or which configuration used as this is your homework that you will find or you will go through the lecture that if it is in common base, in that case how the this configuration work, like some of them work as the impedance matching. I think you have learned you have go through, if you have go through the lecture, then you can get the question that if it is common base, then how it is acts like if some of the configuration acts as a impedance matching, some of the configuration acts as a amplifier. So you will go through the lecture, I think. So here the answer is the common emitter. So common emitter acts as an amplifier. So but you guys will go through the lecture number 5. Then you can unmute yourself and you can tell me because it has high gain and high impedance. Okay. Option number, yes, the right option is option B because it has high gain and high impedance. Next is the question number 25. So this is the small numericals. So you will please solve these equations and please give the right answer. I am coming back in 1 minute.
Ma'am, option A 0.02 milliamps, ma'am.
Ma'am, option A. Yes, ma'am. Option A, ma'am.
Okay. Anyone else? What is the right answer?
Option A.
Okay, Tarun, I got your answer. Anyone else? This is a very simple numerical question. I think all of you can give the answer. Tarun? Oh, okay, Tarun, I think got the answers. Sure. Samuel? Ravi?
Yeah. Tell me.
Yes. What is the right answer?
Yes.
Okay.
Okay.
Kavya, what is the right answer?
0.02 milliamps, ma'am.
Can you little bit explain how we calculate this?
Alpha is equal to IC by IE.
Yes, ma'am.
So, point number IC is equal
Step
to
by step you can explain now. At first, what have you done? Step by step, can you explain? Actually, your voice is also not clear.
Yes, ma'am. Alpha is equal to
Okay. What?
IC by IE.
Okay. Then
Alpha is equal to 0.98.
you have calculated the value of IC. What is the value of IC?
IC is equal to 0.98 milliamps.
Okay.
Then IE is equal to IC plus IB.
Okay.
So IE equal to 1 milliamp. So IB is equal to IE minus IC.
So the right answer is 0.02 milliamps. So if anyone have any doubt to solve this numericals, please tell. I want the answer from all of you. Jayasri, have you solved the question?
Yes.
What is the answer?
0.02 milliamps.
Okay. Kavya, what's the right answer?
Ma'am, it's 0.02 milliamps, ma'am.
Okay, Samuel, what is the right answer? Okay.
Just doing, madam.
Okay. I'm waiting. Now tell me what is the right answer and how you have calculated. This is very simple question, I think. And when we are solving this type of question, I think your basic also clear. All the things sir have taught in his lecture. So if you have little bit doubt from the basics, so we can solve it. The next session, half question will from the numericals and half question from the theory. Because as we are going to solve the numericals, so we have to clear our theoretical portion. Please someone solve the question. And please explain how you have solved the value of IB base current. My voice is not clear. Hello?
No, it is clear, ma'am. You're audible.
Clearly.
Tarun, please check your connection. I think you have network issue.
Answer A, madam.
Please explain how you have solved this question. Here IE is given and alpha is given. What is alpha here? Someone?
0.98. 0.98, madam.
How you have calculated IB is 0.98? At first tell me what is alpha here?
Alpha is 0.98, madam.
No, not the value. Actually, I am telling about the equation. How you have calculated the alpha? It means alpha equal to what? Can anyone tell what is the equation of alpha?
Ma'am, alpha is the current gain in common base configuration.
IC by IE, madam.
Okay.
Alpha equal to IC by IE.
Yes, IC by IE. Then here IE is
Yeah.
given. Then what is the value of IC? Someone?
Both are getting same. Okay.
Alpha is given, IE is given, then what is the value of IC?
Alpha IE.
Yes, IC equal to alpha into IE. Then what is the value?
Yes.
So alpha is 0.98 and this is into 1.
0.98 milliamps.
Yes, the 0.98 milliamps is the value of IC. Then what is the value of
Yes.
IB?
IB minus IC.
Yes. Then what is the exact value?
0.
How it is 0? IE equal to, you see, you have calculated the value of IC which is 0.98 and here IE is given which is 1 milliamps.
Sorry, madam. 1 milliamps minus 0.098.
Okay, so what is the value? What is the final value?
0.02
Yes.
milliamp.
Oh.
Sorry, correct. 1 milliamps minus 0.98 milliamps.
Okay. So the right option is option A.
IB equal to IE minus IC. Finance. Thank you.
So next we are moving toward the question number 26. If the base current in a BJT is 30 microamps, when the emitter current is 7.2 milliamps, here you have to, at first you have seen the unit here. So the base current it is microamps and the emitter current is milliamps. Then find out the value of beta. At first tell me what is beta. Kavya, what is
Ma'am,
beta?
beta is IC by IE.
Okay, and what is the name of beta? Like it is a gain, something gain. In what condition it is gain?
Ma'am, it is the current gain in common emitter configuration.
Okay. So please solve the equation. Sorry, solve the question. I will ask each and everyone. So you have to explain how you have solved this question. So please solve. What is the value of beta? Here IB is given and IE is given. And you have to calculate the value of beta. And beta is IC by what?
Ma'am, option C, 230.
Okay. Anyone else? Kavya, what is the right answer and how you have calculated?
Ma'am, option C will be the right answer. 239. Beta value is 239.
Okay. Anyone
I have
else?
calculated IC I have calculated in the formula of IB and IE is given. So IC will be IE minus IB. So I have put the values and I have converted the unit also. The emitter current is in milliampere. I have converted in microampere, 7200 microampere. So 7200 minus 30, that is 7170. will be the value of the collector current IC 7170. Now I have divided the 7170 with 30, which is the base current. So 7170 divided by 30 will be coming as 239.
So next we are moving toward the question number 27. For a given BJT, alpha DC equal to, here alpha DC is, hello? Please come here.
Ma'am, explain the previous one.
Okay. Actually, we have to find out the beta. What is beta? This is the current gain. So IC by IB is the beta. So here emitter current is given, base current is given. So you can find out the IC. Na? Here you have to take the equation that IE equal to IC plus IB. So from this equation, you have to, at first you have to calculate the IC. Then beta equal to IC by IB. Then put this value and you will get the answer. You can calculate. I am waiting for you. IE equal to IC plus IB. Then put the value. At first convert in 1 unit, like microampere. You can convert in milliampere, or you can convert milliampere to micro. In 1 unit you can calculate, and then you have to find the IC, and then put the value of IC, beta equal to IC by IB. Have you got the answer? Like I equal to, okay, some more options here. I equal to IC plus IB. So IC equal to IE plus IB. IC equal to, if we are converting this 13 micros to milli, okay, then IC value will be 7.17 milliamps.
Yes, ma'am. IC equal to 717
milliamps. Then beta equal to IC by IB. IB, sorry, IC by IB. So IC equal to 7.17 and IB equal to 0.03. We are taking the both is in milliampere. Okay. So
yes, ma'am, got it.
Yes. So the value is 239. Okay. So this is the question number 27. If any of you are facing any issue, then you can ask. If it is not here, you can personally mail me. The question number 27. So for a given BJT, alpha DC, here it is the value of alpha. So alpha equal to 0.98, i.e. emitter current is 2 milliampere. So calculate the beta. So here alpha is given, emitter current is given. You have to calculate the beta. If you know the formula, then you can easily got the answer.
Option A will be the right answer, 49.
Ravi, what is the right answer?
A.
How you have calculated?
Beta equal to alpha by 1 minus alpha.
Beta equal to alpha by 1 minus alpha.
Yes. So the
From
right
that we
is?
get
okay. So here just directly put the equation beta equal to alpha by 1 minus alpha, and the right answer is option A, 49. So next the question number 28. The modulation of the effective base weight by the collector voltage is known as early effect. So it is true or false?
It is true, ma'am.
Can you little bit explain what is the modulation effective base weight?
Yes, ma'am. I can explain. That is when we are operating the BJT in the active mode of operation. So that time my collector base junction is in reverse bias condition, and we all know that when it is in reverse bias condition, the depletion will increase, or it will be wider. So if we increase the reverse bias mode, then we will be finding that the depletion width of the collector base region will be more. So then, effectively, as the VCB is increasing, the collector base width depletion region is increasing, so the base width, effective base width is reducing. That effect is called the base width modulation effect, and
Yes.
as a result of that, that effect is known as the early effect.
Yes. So all of you got the answer. So the right option is option A. It is true. And what is the base width modulation? When we are in active mode, when we are increases the reverse bias voltage.
Can you speak louder? Little bit louder.
Okay. So when we are increases the reverse bias voltage at the collector base side, what happen in that case? The junction width, the collector and base junction width is increases because it is in reverse bias voltage. Okay. So what happened when it is in forward bias? The junction width is decreases, and when it is in reverse bias, the junction width is increases. So when we are connecting this collector, well, as we are taking an example, the NPN transistor, it is in active mode. So emitter base is in forward bias and the collector base it is in reverse bias. So the emitter base, there is a thinner width of the junction as it is in forward bias, but as we are increasing the reverse bias voltage at the collector side, collector base junction, the width also increases. So the active area of the base, it is decreases because the doping in the collector side is greater than the doping in the base. As we have discussed earlier, that the higher doping in emitter, then it is collector, and lighter moderately dope in the collector, and the lightly doping in base. So where the lightly doping, so the base width is increases in that side. The junction width is increases that side because the doping is less. That's why it is slowly, when we are increases the reverse bias voltage, the width of the base is also decreases. This is called the effective base width modulation. So it is clear, or if anyone had any doubt? Hello. Kavya? Am I audible? Hello?
Yes.
It is clear to you? Hello?
No, ma'am.
Not clear. Shaurabh, can you explain?
Yes, ma'am. In the active mode of operation, when we are using the active mode of operation in BJT, that time the collector base junction is kept in reverse bias condition and the emitter base junction is kept in forward bias condition. So when we are applying a reverse bias to any PN junction, that time we can see that the depletion layer of that PN junction will increase. The depletion layer will become more wider during reverse bias, and in forward bias the depletion layer will be thinner. So if we keep on increasing the reverse bias in the collector base junction, then the depletion region will also at the collector base junction will increase because of the increase of the reverse bias. So due to this increase of the reverse depletion region, the base region will decrease because the base region will be covered up by the depletion region due to the reverse bias voltage. So the base region, or the effective base where I will be getting the base region, that will become more smaller due to the increase of the reverse bias. So as the base width is becoming reduced due to the increase of the VCB reverse bias voltage, that physical mechanism is known as the base width modulation, or the effective base width modulation. The base width is reduced due to the increase of the reverse bias in the collector base junction.
Yes. Kavya, now it is clear to you? Hello. Okay, we are going towards the next question. What is the factor that limits the maximum current a BJT is capable of handling? The first option is junction area of the collector region. The second option is drain width. Third option is the emitter width, or the option D is none of the above. So what is the right answer? answer, Ravi?
Madam.
Sorry, you are not audible. Option A.
C.
Option C, emitter width. Okay. Anyone else? What is the factor that limits the maximum? Someone option A. Okay.
And option A will be the right one.
Can you explain?
The junction area of the collector region is limiting because the junction area, the collector junction is reverse bias. So due to the huge depletion or the wider depletion region, the current or the maximum current flow in the collector region can be controlled by the use of the depletion region, as the depletion region is thicker in the collector junction, so that more number of carrier cannot come and so that the device does not get destroyed.
Yes.
So I think the option A.
Yes, the right option is option A. The junction area of a collector region. And also the more surface area and more is the heat dissipation.
Yes, the surface area of the collector is more, so that the heat dissipation will be controlled.
Yes. So next question, it is a small numericals. So please solve the question. A transistor connected in a common base configuration has the following reading. IE, the emitter current is 2 milliamps and IB is 20 microamps. So find the gain alpha. What is the right answer? Alpha equal to IC by IE. So here IE is given. So what we have to find? IC by we have to find the IC value. And
Ma'am, option C
Ma'am,
will be the
option
right
C.
one. 0.99.
oh,
Ma'am, option C.
okay. Good. Option C is the right option. So this is a small numericals that in common emitter amplifier, collector load is 4 kilo ohms and the quiescent current is 1 milliamp. It means the current flowing through this load is 1 milliamps. So find out the operating point if the VCC is 10 volt. So here what at first listen carefully. What here given? VCC is given, which is 10 volt, and then the current flowing through this 4 kilo ohms is 1 milliamps, and the collector load is 4 kilo ohms. So at first VCC is 10, then there is a resistance which is 4 kilo ohm, and the current flowing through this resistant is 1 milliamps. Then find out the operating point, and operating point means the VC comma IC. It means at 1 milliamps or whatever current, whatever the voltage is it, okay. And so find out this operating point.
Ma'am,
Wait.
option D, that is 6 volt, 1 milliampere will be the right answer. Last option.
Can you explain how you have calculated?
Yes, ma'am. The formula for the calculation of VCC by the output KVL will be VCC will be equal to VCC minus of ICRC. So the value of VCC is known, that is 10 volt, minus of ICRC. So IC is given 1 milliampere, RC is given as 4 kilo ohm. So ICRC will be 4. So 10 minus 4 will give me 6 volt.
Yes.
So the operating point will be the VCQ comma ICQ. So IC already I am knowing that is 1 milliampere. So from that 6 volt I am getting VCE. So 6 and 1, that is the point, operating point. 6 volt, 1 milliampere. VCE IC.
If anyone have any doubt still, or I will move towards the next question.
Repeat the equation. VCC is equal to VCQ minus IC into RC.
Sure, can you explain again?
Yes, ma'am. The value of VCE, that is the collector to emitter voltage, is equivalent to VCC minus ICRC.
Yes.
So the VCC value is given, that is 10 volt, minus ICRC. IC is given as 1 milliampere, RC is given as 4 kilo ohm. So if we put the value VCC minus ICRC, we will be getting 10 minus 4 into 1. So 10 minus 4, that is 6 volt. So 6 volt is the VCE value, that is the collector to emitter voltage value is 6 volt, and collector current is already given as 1 milliampere. So from that we can get the operating point, that is VCE comma IC, that is 6 volt comma 1 milliampere.
Can you repeat what is that operating point?
Operating point is the Q point, that is when we are connecting the load line, from the IC in the y-axis and VC in the x-axis. If we plot the output characteristics graph for the common emitter configuration where the base current is the input current. So if in the active region, if we join the 2 points, that is the ICQ and the VCQ, we will be getting a load line, and the intersection of the load line with the output characteristics curve will give me the Q point. So that is the Q point or the operating point.
It means the VC comma IC.
Yes.
So here IC is given that 1 milliamps. So we have to find the VC, where the VC is equal to VCC minus IC RC. Okay. So the right option is option D. And this is the last question. So here for the common emitter circuit which is shown here, what will be the value of IE and VCE? So please calculate. This is a little hint that you have to find one equation. So first you can take a loop that VBB to this VBE from base to emitter, you can take a loop, and then the another loop from collector to this emitter side, you can take the another loop. So from the first loop you have to find the value of IB, and then from the second loop from this VCC to this VCE, you have to put this value of the IB. So you will get a equation of the which is related to this IE and VC. So then you put each one of the equations value there, and then see it is matching or not. This is the common emitter connection. So at first, from the first loop from VBB to VBE, this is the first loop. So here you have to at first find the IB value, and then from the second loop which is coming this way, this VCC to VCC, then RC, IC, then VCE. So here you have to put this calculated IB value, and then you will get an equation which is which contain only the IE and VC. Then you have to put each and every equation's value there, and you have to find it is matching or not. Have you calculated?
Yes, ma'am. I got the value of I. I am now calculating the value of I.
Okay. So first you have to take the first loop, that is VBB, then minus ICRC, then minus the VBE value. Okay. So you have to you can get the equation that 4 minus 220 kilo ohm into IB, then minus 0.7 equal to 0. This is the first equation.
Yes,
and
from that we get the value of IB.
Yes,
base current.
and what is the value of IB?
It is 0.015 milliampere.
Yes, this is 0.015 milliampere, and then you have to take the another loop from the VCC. So the VCC minus RC IC, and then minus VCE. So here what we have to do, then here RC value is given, and we have to convert this IC into this what we know, IE equal to IC plus IB. So IC equal to IE minus IB. So
yes.
Here 2IC equal to 2IE minus 0.01. I think the IB value we have got 0.015. Yes. Then so the final equation will be 2IC plus VC equal to 10. So 2IE plus VCE equal to 10. 10.3 I think. So please calculate and then put the equation value. which one is
Ma'am, please wait for 1 minute.
Okay. IB value is 0.015 milliamp.
Yeah, ma'am, 0.0.
Ma'am, is the value of beta or alpha is anything given?
Actually, no, this is not given. That's why you have to find if the the answer from this solution option is given.
Ma'am, if we take the loop analysis in the output, then it should come like the VCC minus of ICRC minus VCE equal to 0.
0, yes.
So, in that case, I am getting the IC is unknown. So if I replace the IC with IE minus IB, that case also the VCE value is unknown.
Yes. So you are getting the equation 2IE plus VCE equal to something. Okay.
Yes.
Here now you have to see that if you are taking the current value, then you are getting the same voltage value or not. Here beta is not given.
Not got you. I got the value up to VCE is equivalent to VCC minus of RCIE plus IBRE. RC.
See, here the equation will 10 minus ICRE, ICRC minus VC equal to 0. Okay. So
Yes,
2IC plus VCE equal to 10. Then you have to just put the value of IC. What is it? 2 into IE minus 0.015 plus VCE equal to 10. Then you have to just take the value 2IE plus VCE equal to something, equal to some value, 10.3 or something. Okay. Then you have to take the first option that the current value is given. If the current value is given, then you have to find the voltage value is same that first option, that if you are putting the voltage value 3, then the current value is coming 3 milliamps or not.
Trial error I have to do. Yes, then it is okay. Trial error I have to do like that. Okay.
Because here if the beta value is given, then it is little bit easier. So if this type of numericals is given where the beta value is not given, so here you will get the equation, then you have to find out the answer from this option.
How do you get the VCU value?
Have you
How do you
calculated
find VCU value?
have you calculated the value of IB?
Yes.
Okay. Then this is the first loop that you have taken from VBB to VBA. Okay. And the second loop you have to take from VCC to VCE. So if you are taking the second loop, then what is coming? VCC minus RCIC minus VCE equal to 0. Okay. If you are taking this equation, then
Is it not plus VC?
Why plus VCE? If you are see
Plus minus VC.
no, actually here we are, if you are taking any loop, then how you calculated this will be positive sign or negative sign. If we are moving towards the positive to negative, then here we are taking that it is negative. Okay. So if you are taking the VCC is positive, so we are moving from the negative to positive side. Then where in the resistance where the current is entering, so this is the positive side and the opposite is negative. We are assuming that. That's why the minus ICRC, and then plus V2 minus side we are moving. So this is minus VCE. So 10 minus ICRC minus VCE equal to 0. Then what happened? Just put the value of VCC and RC value, and IC here we have to find the IE. So you can write here instead of IC 2 into IE minus 0.015. It means the IE minus IB plus VCE equal to 10. Okay, we got the equation. Then the final equation is 2IE equal plus BCE equal to 10.3, I think. 10.03 or 10.3 something. I think 10.03. Okay, and then just put the option value there. Take 3 milliamps current and see what is the voltage is coming, what is the value of VCE. If it is matching on the first one, then will be the right option, and if it is not matching, then put the IE value 4 milliamps, then see what is the current value.
Better use pen and pencil.
Okay, next class I will
be very clear. Yeah. This kind of problems to
okay, just a minute. Just a minute.
Ma'am, the option, it is coming, the last one.
Yes, the right option is the last one.
4 volt, 3.02 million.
Can we explain here how we have calculated?
Yes, yes, I can explain. That is the, after putting up by your analysis, I am getting the value of VCE, that is the collector to emitter voltage, is equivalent to 10.03 minus of 2 IE. 10.03 minus of 2 IE. Now if I put the value of VC from the option, if I take the last one, if I put VC as 4 volt, so 4 minus 10.03, so I will be getting the value as minus 6.03. So negative in both sides will get cancelled, so 6.03 divided by 2, I will be getting 3.015, which is almost approximately equal to 3.02.
Yes, the right option is option D. Ravi, I think this is the very easiest question. See here, what you have to done, just you have to take this loop. The second loop is VCC minus ICRC minus VCE, which is the second loop, equal to 0. Up to this, everyone is clear, na? Ravi?
Yes, madam. I know, but how do you find VC value? That's what I'm asking.
Yes, you have to at first you have to find the equation where only the IE and VCE is there, okay, and then you have to just take the option, like if the equation is 2IE plus VCE equal to 10.03, then how you will find the answer? You have to take either the voltage value or the current value. At first take the voltage value, okay, then VC value is 3 volt. We are assuming that the first option 3 volt. Then just put the VCE value 3 volt in that equation, and then what is the current value IE? Are you getting my point?
Okay.
And if it is not matching, then in this equation you have to take the voltage value 4 volt and then see the current IE value. Just you have to convert this IC equal to IE minus IB. And here we have calculated from the first loop that IB equal to 0.015 milliamps. It is clear to everyone? Then you can do. We will meet again Tuesday 7 p.m. If you have any doubt, please ask. Otherwise, you can do. We will meet again Tuesday 7. Yes, Kavya. Hello. Now you can see the slide. Hello, am I audible?
Yes, ma'am. Yes, yes, ma'am.
Just so first take this loop, okay, and second take this loop. So what we are getting from there, IB equal to
VB minus IBRB.
0. I'm just telling this value, okay.
0.015 milliampere.
Yes, 0.01.
Oh, IB got it.
Okay, IB you got. So here what is the equation from this VCC minus
ICRC.
minus VC. Equal to 0. Okay, so then put the value 10 minus IC value, it is not given, so you can write here IC equal to IE minus IB. IB value is given here. Just put the value of IB and then multiply with RC. It is
2 kilo.
2 kilo ohms. Okay, you have to calculate it. I'm not going to do that. Then minus VC. Equal to 0. Okay, then what you have to do, you have to just calculate all these things and you will got the final equation that 2 into IE. Just keep this VCE and this minus 2IE plus 2IB, okay, and this 10 is positive, so just take this 10 in opposite direction. So here finally you will got this equation 2IE plus VCE equal to Saurabh, what is the value? 10.03.
10.03, yes, ma'am.
Yes. 10.03. Now what you have to do, here you can see the option, okay, this is the equation, like this is the equation number 1. Okay, so what you have to do, at first take any one of this value, like if you take the voltage 3 volt, okay, just put the VCE value 3 volt and calculate IE value and tell me what you are getting. And then equally after that, if it not matching, you can calculate that you have to take the VCE value 4, okay, the second option, then see what is the value of IE, it is matching or not, or it is not matching, then take the VCE value because here we have to find the IE and also the VCE, but the beta is not given. So how we can get the result? Then you have to put the VCE value 4.2 and then see the IE value is 3.021 watt, and the last option is the 4 voltage and you can get the 3 point. This is the right option. So here you can directly put, also you can check there the VC value, you have to put 4 voltage and you can calculate the IE value. Here only the matching value is the 4th option. So now it is clear, or I have to do this equation, all these things. Hello?
Okay, madam. It is only trial and error basis you have to calculate.
Yes. If the beta value is not given, then you have to at first you have to find this IB value, and then the second loop you can find this equation, because here you can find the value of this IA IBC, because two things are missing. So if the beta is given, then it will be easy, but here it's some beta is not given. So how can you find that type of numericals? So in that case you can here two things is missing, so you can find directly from the option. So any of the option you can take, like you can take the current value, then you can find out the voltage value. If it is matching, then okay, the right option is first option. If it is not matching, then go for the second option, and then another thing.
Okay.
So here you have, if you are taking the VC value 4, then the you can find the IE value, it's nearly 3.02 milliamps. Okay, so you can leave up to this.
Thank you, ma'am. The next session, ma'am, will be on Tuesday.
My session will be every Tuesday 7 to 9, and another TA is taking Monday, I think.
Yes, Anjali ma'am is taking on Monday. Okay, ma'am. Thank you, ma'am. Take care. Good night.